Good morning. Welcome back to our channel. Today we are going to learn PIC16F877A introduction. If you are new to our channel, please subscribe and press the bell icon so you will never miss our latest videos. Let's get started. PIC16F877A microcontroller introduction. If you are a beginner in embedded systems, this is one of the first microcontrollers you should understand because it helps you build a strong foundation for embedded programming and hardware interfacing. By the end of this video, you will learn what is the PIC16F877A, why is it so popular, features of PIC16F877A, pin configuration, memory architecture, applications, real world examples. Before we start, please subscribe to our channel and press the bell icon so you will never miss our latest videos. What is PIC16F877A? PIC16F877A mean it is full form of PIC16F877A. PIC mean peripheral interface controller. 16 mean that is series family. F mean flash memory. 8 mean 8-bit microcontroller. 77 mean product number. A mean analog supporting devices. So PIC16F877A is an 8-bit microcontroller developed by Microchip technology. It is designed for embedded applications where a dedicated controller is required to monitor sensors, process data, and controls electronic devices. Unlike a computer process, the PIC16F877A is built specifically to perform one task, dedicated task efficiently. Why is PIC16F877A popular? Many beginners ask, why do colleges still teach PIC16F877A? Because it is easy to learn, low cost, reliable, simple architecture, rich in peripherals, excellent for academic projects, widely used in embedded laboratories. Even though modern controllers like STM32 and ESP32 are available, learning PIC16F877A helps students understand the embedded programming fundamentals. Real-time example: imagine an automatic water tank controller. The system continuously checks the water level. When the tank becomes empty, the PIC16F877A automatically turns on the motor. When the tank becomes full, it turns the motor off. The entire process happens automatically because of the microcontroller. Another example: think about a digital temperature monitoring system used in hospitals. A temperature sensor sends data to the PIC16F877A. The microcontroller processes the data. If the temperature exceeds the limit, it activates buzzer or displays a warning message. This is simple embedded applications built using PIC16F877A. Features: now let PIC16F877A 8-bit CPU. PIC16F877A is an 8-bit microcontroller. It is processed 8 bits of data at a time. Why is mentioning 8-bit data? Just I will explain. This is here is mentioned for RB not to RB7. This is the 8-bit. Then this is for mentioned for port B. Then port C is mentioned for RD4, RD4, RD5, RD6, RD7, 4 pins. Then RD0, RD1, RD2, RD3. Here also 4 pins. Total 8 pins. Then port C also RC5, RC4, RC5, RC6, RC7. Then RC0, RC1, RC2, RC3. This is also 8 bits. So every microcontroller, PIC16F877A is controlling for the 8-bit microcontroller. This is max suitable for small and medium embedded applications. Flash program memory. It contains internal flash memory. Flash memory stores the program permanently. Even after power is removed, the program remains stored. This allows programmers to erase and rewrite the program multiple times. Okay, PIC16F877A mean PIC is peripheral interface controller. 16 means serial number. F mean flash memory. It is you can write it for a flash program in 1 lakh times. Maximum 1 lakh times you can write and read programs. It is possible. 8 mean you are using microcontroller is 8-bit microcontroller. 77 mean it is for product number. A mean analog devices. It is included internal RAM. RAM stores temporary data while the program is running. Then WPROM, PIC16F877A also provides WPROM memory. WPROM stores important information even after power is turned off. Example: password storage, user settings, calibration values, machine configuration, smart energy meter. Okay, input and output pins. Input and output pins in the controller provides 32 programmable I/O pins. These pins are used to connect LED, LCD displays, keypad, relays, sensors, motors, and buses. Example, I will tell. 33 pins. Users pins is 33 pins. I told that is for port B is 8 pin. Port D 8 pin. Port C 8 pin. Then port A 6 pins. Okay, RE0, RE1, RE2, RE3, RE4, RE5, 0 to 5 it is 6 pins. Okay, then port E also 3 pins. Then total 8, 16, 24, 30, 33 pins. Okay, this is the usual programmable pins. Balance 7 pins, 1 pin is MCLR. Okay, master clear. 2 pins is VDD, then VSS. Power sources. Okay, VDD mean 5 volt, VSS mean ground. Total 4 pins. Total 5, 4 plus 1 5. Accelerator 1, accelerator 2. Total 7 pins. Total 33 plus 7 40 pins. But usual programmable pin is 33 pins is possible to. You can write it for I/O programmable pins. Okay, anyone is doubt, you can write it in comment box. I will reply in shortly. Timers. PIC16F877A contains multiple timers. Timers are useful for delay generation, event counting, PWM generation, frequency measurement. Then ADC. Many sensors provide analog signals. The internal ADC converts analog signals into digital values. Examples: temperature sensor, gas sensor, light sensor, pressure sensor, also one analog sensors. Communication interfaces, UART, SPI, and then I2C. These protocols allow communications with LEDs, WPROM, Bluetooth modules, Wi-Fi modules, GSM modules, LCDs. Okay. Pin configuration. PIC16F877A comes in 40-pin dual line package. Okay. This is for single line. This is for another one line. So this is the dual line configuration. These pins are grouped into ports of port A, port B, port C, port D, and port E. Each port performs input and output operations. Some pins also support ADC, UART, SPI, PWM, and interrupt functions. Clock sources. Every microcontroller needs a clock. PIC16F877A commonly uses a 20 MHz crystal oscillator. This crystal provides accurate timing for an example execution. This is everything I will explain for in data sheet. 1 minute you can wait. I will show the data sheet. So learning mean you can download for data sheet. Example, I am learning for PIC16F877A. This data sheet is mentioned for PIC16F877A, but is mentioning for X. X mean it is for this is 0 to 9. Any microcontroller you can use it for this data sheet. Okay, 871, 872, 873, 874, 875, 876, 878, 878, 879. Any 870. Any microcontroller you can reference for this data sheet. Now you can learn for PIC16F877A. Okay, 28 pin and 40 pin and 44 pin enhanced flash microcontrollers. Okay, I will show the features of PIC16F877A. You can scrolling down, then first pages you can mention for this data sheet supporting for devices including the data sheet PIC16F877A, PIC16F874A, PIC16F876A, PIC16F877A. Okay, this high performance RISC CPU. Okay, it is supporting for 20 MHz clock input. It is 200 nanosecond instruction cycle. Okay, it is coming output for 200 nanosecond instruction cycle. Then peripheral features: timer 0, timer 1, timer 2. Then capture and compare, PWM, SPI communication, I2C communication, UART communication. Then how many I/O ports is there? Then block program memory. Okay, bytes. How many bytes you can upload the program? 14.3 KB. Single word instruction 8192. Data SRAM is 368. W from bytes is 256 bytes. I/O pins is 33 I/O pins is 10 bit ADC. 8 channel is the CCP PWM. Compare, capture, PWM to SPI communication possibilities, yes. I2C possibilities, yes. UART possibilities also, yes. Timers 8 bit or 16 bit. 2 8 bits, 1 16 bit. Comparators 2. Okay, this is mentioned. Then 10 analog features, 10 bit up to 8 channel analog digital. Special microcontrollers 1 lakh time. You can erase, write, cycle, enhance, flash program memory, difficult. Okay, this is for the typical clients. 1 lakh time erase write cycle data W from memory. Okay, anyone, you can, any doubts, if you have any doubts, you can write it in command box. I will reply in shortly. Then development tools also. The program, the PIC16F877A commonly used software includes MPLAB IDE or MPLAB X IDE, then XC8 compiler. Simulation tools, Proteus, MPLAB simulator, program hardware, PIC2 programmer. Applications, 877A is widely used in applications: home automation, traffic signal control, water level controllers, digital thermometers, smart energy meters, security systems, industrial automation, robotics, agriculture automation, medical equipment. Okay, industrial example: conveyor belt system. Sensors detect the products moving on the conveyor. The PIC system of 877A counts each product. If a defective product is detected, the controller activates the pneumatic arm to remove it. The improves production quality and reduce the manual work. Advantages: the PIC system of 877A advantages: low power consumption, high reliability, easy programming, low cost, built-in peripherals, excellent for learning embedded systems. Limitations: limited processing speed, limited RAM, not suitable for high-speed applications, and no built-in Wi-Fi or Bluetooth. For advanced IoT applications, develop centrally ESP32 or STM32. I hope you now clearly understand the concepts of PIC16F877A microcontroller. If this explanation helped you understand the concept, please subscribe to our channel and press the bell icon so you never miss our upcoming videos. Thank you for watching this video. If you have any questions, leave them in the comment section. Need help with final year projects or mini projects or the IEEE process, contact and WhatsApp. Don't forget to subscribe and press the bell icon. See you in next class. Thank you.